the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
Thank you, Dr. Sarkar, for this kind introduction. I just wanted to also thank, I see Dr. J in the room as well. So thank you so much for supporting here. Welcome, everyone. Thank you for joining. My name is Samir Neve. I'm an environmental engineer here at WSP. And it wasn't too long ago that I was on the other side of this Zoom call moderating these sessions. And it just feels surreal to be a speaker here today. So just in terms of logistics, right now in front of my screen, I don't have the Zoom window open. So Parisa or someone else, please give me a shout out if you want me to do something different, okay? So as for the seminar today, I'm going to connect two ideas that don't usually come together. One is the permitting process for building the solar and wind farms, and another is the way to turn the vegetation that we clear for these projects into something valuable called biochar. So the title says it all. It's from clearance to cleanup. And for the purpose of this presentation, I'm just limiting the projects to solar and wind. But there are other redevelopment and infrastructure projects that this concept can be translated to. Biochar was the center of my PhD research with Dr. Sarkar, and I just love talking about it whenever I get a chance. So here's what we'll discuss today. Part one walks through the permitting process from picking a site to getting final approval. And then part two introduces biochar and shows how this cleared vegetation can become remediation material instead of just landfill waste. So no prior knowledge of permitting or chemistry is needed. I'll keep it accessible for everyone, but I'm more than welcome to take questions and discuss more on either of these two parts. So let's start with the permitting. This is the foundation of every onshore renewable energy project, be it solar or wind. When you enter the consulting world or the environmental industry in general, this is the doorman that will always greet you in the first few projects. You cannot escape this. So the three numbers to frame this discussion are on the left side of the screen. The first being the 2 to 5 years, which is the average permitting timeline for utility scale projects. Second is the 40 plus permits that may be required across federal, state, and local agencies, depending on the size, location, and the potential impacts of the project. And the third is the permitting delays that are consistently the number one barrier to renewable energy development in the US, actually even globally. But here's the reframing of this whole problem, that permitting isn't just paperwork. It's the framework that ensures that these projects are built responsibly. And when done well, it balances the speed, the cost, and the ecological responsibility of the project. So that quote on the right is the lens for everything I'll share today. So when people hear permitting, they often imagine a linear checklist that you just get done with ease. But why it takes 2 to 5 years is because these steps, although they are shown sequentially, they rarely happen all at one time. It's a multi-track process involving landowners, engineers, regulators, scientists like you and me, and communities that these projects belong to. So I'll just walk you through these 5 phases to the best of my ability. The step one is the site selection. Everything starts with the land and the resource viability. So developers first secure the land through leases or some other options, often years before the construction, maybe 5 or even in some cases 10 years before the construction. And at the same time, they evaluate whether the site can actually support any of these power generation efforts. Is there enough sun for the solar project? Is there sufficient wind speed and consistency for the wind turbines? But this isn't just about physics. It also flags fatal flaws. So the goal here isn't perfection. It is to decide whether the site is worth investing all these millions of dollars in the detailed studies. Now, when you move on from site selection, you get into the environmental review. So once a site looks promising, that's where we do the intensive review. And this is where biology, ecology, history, and engineering intersect. So pretty much all what you have learned through in all your courses so far, or in some case that you're about to learn, all these things will come together in this environmental review. So the teams that are undergoing these due diligence processes conduct something called a NEPA analysis, which determines whether the impacts are minimal, moderate, or significant. And we'll talk about this a little later. There are also wetland delineations to identify the regulated waters in that particular area. There are wildlife and habitat surveys, which sometimes occur over multiple seasons depending on the wildlife that is expected in that area. And then there are cultural and archaeological assessments to protect the historical and tribal and cultural resources in those particular areas. More importantly, this step is not just about checking boxes, how we talked about earlier. We use this information to determine what impacts can be avoided, what must be minimized, or what will require mitigation or offset. So this phase forms the technical backbone of the review and assessment, and it often drives the project design long before permits are even issued. So you might end up doing these studies and then deciding that we might need an alternative route, or we might need a different piece of land. And to carry all those large wind turbine blades, you might need a different path access. So those can be just some temporary measures, but they need to be undertaken. The step 3 is the agency consultation. And at this point, the developers are actively coordinating with multiple agencies and often simultaneously. And this step is critical because all these agencies need to be in alignment. And this has to happen much early in the process so that they can prevent any major delays later, especially during the formal review as such. And once all this is done, there is public engagement. So a project can be technically sound and also legally compliant based on all these permitting things that we do, and it still would fail without acceptance of the community that is sitting in. So the communities raise real concerns like visual impacts, property values, traffics, noise, the new trend that came in and died down of environmental justice, and the long-term land use. So the good projects start public engagement much before the permit applications are filed so that they can use the feedback to refine these layouts and the mitigation plans. And this step kind of determines how smoothly the project will go, if there are going to be any backlashes during the process, or if it can just go smoothly. We are currently working on a project which is clearly titled, I mean, of course, rhetorically as messy because of the type of complications there are in the process. So the next step is the permit approval, but it isn't still the finish line. It is actually the starting point. Once you get all these approvals, you eventually start the construction, monitoring, and reporting of the entire process. In all these processes, you have some compliance commitments that need to be followed. There are some stormwater permits that would be required, some wildlife protection that needs to be done. And all these mitigation commitments are for years or decades, because it once you eventually make change to that particular landform, it's going to stay there for a bit, right? So you have to make sure that it is good for the environment. So site selection is arguably the most critical step, and solar and wind have very different needs for both of them. Solar needs about 5 to 10 acres per megawatt. It needs a fairly flat terrain, south facing orientation because we are in the northern hemisphere, and a minimal shade so that the panels can generate electricity at their most efficient format. The next thing is the wind. For the wind farms, you need to have about 40 to 80 acres per megawatt. That is much more land, at least what eight times more land than solar. But the good part of it is it can be on ridge lines, it can be on mountainous areas, which you might have seen if you travel into upstate New York and some other parts of the US. You need a consistent wind class of 3 or better, and you need to have setbacks of 1 to 3 miles from homes because of the noise and the visual impact. I don't know how many of you have been around the wind farms, but when you stand near, even if the wind turbine is going a bit slow, you see and you hear a lot of humming noise, and it can get irritating over a period of time. So that's the reason why you need to be distant from the wind turbines. So both of these require early screening for grid interconnection, because eventually they are generating the electricity at one place which is meant to be taken to someplace else. So you need to know how the grid interconnection is working. Also, because they are going to be put up in a place which wasn't originally meant for this, you need to have zoning compatibility and overall environmental justice considerations. The key takeaway from this is basically the technology you choose determines where you can build and what permits you will need. So once a site is identified, the environmental review process begins, and there are 6 major review areas
Samir,
that. Yeah.
sorry to stop you, but there is some kind of a static, right? Is that on
Yeah,
my
your no, your audio just is a little bit unclear.
Yeah, getting some static on your side.
I see. Let me try and change something. 1 second.
Although you are good now, I don't know, maybe it was just a phone or
I don't know.
something.
Yeah, he was talking about wind turbines when it came.
Yeah, is better?
Yeah, I think the wind turbines humming noise has gone now.
Yeah, that's
All right, good.
exactly that. Yeah. All right. So yeah, coming back to the environmental review process, we have multiple regulatory areas which can significantly affect the project schedules if they are not initiated early. So wetland impacts trigger the US Army Corps of Engineers Section 404 permits for any dredge or fill in waters of the US, and it often requires alternative analysis and mitigation. And some of these agency names that you hear from me right now, they might seem alien to you, but once you get into the industry, these are something that you see pretty much every day and you deal with them every day. So if they are not yet familiar to you, please get familiar with them. That will make your job easy. So the wildlife, we talked about wetlands, but wildlife considerations may require the Endangered Species Act Section 7 consultation when threatened or endangered species or critical habitat are present. The cultural resources are evaluated under Section 106 of the National Historic Preservation Act, and this includes coordination with the state historic preservation offices, which are commonly called as SHIPO. So SHIPO offices and tribal nations. So for wind projects, birds and bats are a key focus, with mortality studies and variable applicable permits related to eagle nests and bird nests in general. Nearly all these projects disturbing more than 1 acre require NPDES stormwater permits and robust erosion control and sediment control measures. The visual impacts may also be assessed through viewshed analysis or scenic easements, particularly in sensitive or scenic landscape, because you don't want to disturb the natural beauty of that particular area that you are going to eventually transform into a different project. So each of these processes can add months or even longer to the overall timeline if they are not uh, proactively addressed. So make sure that if there are some kind of restrictions that are going to happen over time, they are all taken in account much before in the process. So coming back to the NEPA, which is the National Environmental Policy Act, it's the federal backbone for all important projects. The three pathways depend on impact level. So the first one is the categorical exclusion. So for this is for the projects with minimal impact. You don't need detailed studies for these. It just takes some weeks to months. But once you cross that, you have the environmental assessment, which is a mid-level review. So if the agency concludes that there is no significant impact, you get what is called a finding of no significant impact, or it's called FONSI. And that triggers the full environmental impact study process. So on the right, you have that environmental impact statement, which is the full process with alternative analysis. So most utility scale solar and wind projects need at least an environmental assessment, and many end up in a full EIS territory. So that can take from anywhere from 1 to 3 years, or maybe more, depending on how complicated the project is. Well, the key to note here is that if there is any kind of federal nexus, be it federal land, federal funding, or a federal permit, this NEPA process applies. So now permits are legal instruments, but social license matters just as much. So four areas that are noted here form part of that social license. Just a note, this is not a technical term. It's something that is embodying all these four items. So public hearings that are required for most of the zoning variances, where residents voice their concerns about noise, property values, and visual impacts. The next part is the zoning approvals, which are the special use permits, some overlay districts, and sometimes renewable specific codes, because not everything can be done everywhere. The next part is the community agreements. These are negotiated deals. The word pilot does not mean a test. It stands for payment in lieu of taxes. So that's one of the funding mechanisms for a project. But you also have benefit funds. You also have local hiring commitments for the project, where they say that if this particular area is impacted, we would like to have labor from this particular area to support the project. And the last part is the environmental justice, which is increasingly required to ensure the projects that don't disproportionately burden the disadvantaged communities. And the quote at the bottom is the single most important lesson from practitioners, which is the start engagement early before you file permit applications. You basically build trust first so that they can support you in the entire process. And when impacts can't be entirely avoided, regulators follow the mitigation hierarchy, and they expect applicants to do the same. The first part of it, and the first preferred option, is to avoid the impact. So you redesign the project to skip the sensitive areas. If you can't avoid it, you minimize the duration, the intensity, or the footprint, of the impact. And the third part of it is the restore part. So after construction, rehabilitate what was disturbed. You can even do it as revegetation or habitat enhancement or something of on those lines. And the last part is, if you can't do any of the first three steps, you offset. So you compensate for what's left through conservation easements or mitigation banking. And the bars get shorter because the priority of those goes down, and that's intention. Avoidance is preferred, offsets are the last resort. So now here's the transition that connects the two halves of this talk. Every renewable energy project clears vegetation, and sometimes it can be over 1,000 acres for more of 100 megawatt solar farm. And it involves everything from trees, shrubs, grass, all removed during the site prep. And typically, all this biomass is hauled off-site to a landfill. It is either chipped or left to decompose. And that's expensive. It generates a lots of emissions, and it's also wastes a perfectly good resource. So the question is, what if this waste was actually a resource? And what if instead of paying to haul it away, we could actually convert it into something that could clean up contaminated land? And that's where biochar comes in. So coming to the part two of the talk, where we'll talk about turning vegetation waste into a remediation grade biochar. And you might find a sense of change in my tone, because I get very passionate about this part since I've worked very closely on this, and I'll continue to do so.
Okay, Samir, do you want to entertain questions on your first part here, or should we wait until your entire talk is finished?
I would prefer at the end.
Okay, all right.
Yeah. So, what is biochar? Biochar is, at its core, biochar is pretty much an engineered form of charcoal. Imagine taking any sort of brush, wood, and the vegetation that was cleared from the site and giving it a second life instead of sending it off as waste. So that material is heated to about 350 to 700 degrees Celsius, depending on what kind of properties you're looking for in an oxygen limited environment. That's the crucial part of it, because this is the process that's called pyrolysis. And with little oxygen present, the biomass doesn't just burn, it actually transforms into something magical. So what's especially elegant is that the byproducts of this process, that's the syngas and the bio oil, they can be captured in this process and reused to help power the system itself, reducing the external energy needed to run it. So you don't necessarily need to put an extra amount of gas to keep it burning. It will also take care of its own process. In other words, it's the process almost starts feeding itself in a bit. So why do we overall care about this powdery material that looks like charcoal and often is misinterpreted as charcoal? It's because its properties are remarkable. So biochar has a surface area between 300 to 800 square meters per gram. And to put that into context, a teaspoon of biochar unfolded, just opened up and unlayered, would actually cover something close to a football field. That's how much of a surface area it has. And that enormous surface area is what makes it so effective at grabbing onto contaminants. The next part of it is the carbon stability. So the carbon in biochar isn't just short lived, but it stays locked away for hundreds to more than 1,000 years, turning the plant waste into a long term carbon storage. Think of it like a bank, which is not going to end. The third part of it is that all these biochars, especially with the woody biomass, are typically alkaline, meaning that it can buffer acidic soil. So if you have acid mine drainage or similar contaminated land, you can actually use this to increase the alkalinity of that soil. The fourth part is that biochar has a high cation exchange capacity, which helps soils hold on to nutrients instead of letting them wash away. And finally, biochar is incredibly versatile. So it can be made from almost any lignocellulosic biomass, which can go from wood chips to brush, agricultural residues, your fallen leaves. In terms of when you do spring cleanup, when you do fall cleanup, all that can eventually be converted into biochar and put back in your own backyard. And one of the studies that Dr. Sarkar did was finding lead in backyards of residents in Jersey City, and this can be one of the potential solutions to that. So, what we usually see is a disposal problem for such a big volume of waste, but instead it can be converted into a tool for soil improvement, soil remediation, and overall climate benefit because it's eventually going to sequester carbon. Uh, just bear with me on this slide. It seems a little more technical, but I'm just going to try and make it simple for you to understand. So inside biochar, you can think of it like a microscopic city of tunnel and cave. So if you look at it on the top left, you see that there are some pores that are big enough for water to flow through, while the others are tiny so that they can trap chemicals in the way that a filter does. So on the surface of those pores are chemical groups that acts like hooks or magnets. So positively charged metals stick to them, nutrients latch onto them instead of washing away, and the organic pollutants get pulled into the carbon structure and they are held there. So at the same time, the carbon itself is very stable. So once these contaminants are captured, they stay locked in place for decades or even centuries. So these chemicals are no longer bioavailable and they can stick to the biochar. And eventually, if that biochar is isolated, you can put it into something like a concrete, or it can just stay in the soil and rest there without having a trouble of these contaminants leaching back into the environment. And that's why the biochar doesn't just work like a sponge, but as a long-term environmental stabilizer. Now, just imagine this being applied in a really contaminated environment and how it can just do wonders. So here's the practical innovation part. So instead of hauling away cleared vegetation offsite, you can actually bring a portable pyrolysis unit to the project site. And there are companies that are coming up who actually have these kind of units that you can put on site. They'll generate all the biochar from the waste that you put in there, and you can take control of the biochar and do what you want to do with it. So the first things first, you eliminate the hauling. You cut about 50 to 80% of the disposal cost by avoiding hundreds of truck trips and heavy truck trips. That also means fewer emissions and less wear and tear of the road and overall the vehicles as well as the transportation system in general. The second part is you end up sequestering carbon. So every ton of biochar produced locks away about 3.6 tons of carbon dioxide equivalent in a stable form that lasts clearly over hundreds and thousands of years. So compare that to composting or mulching, where the carbon will return to the atmosphere as part of the degradation process within a few years. And the last part is you can be smart and generate revenue. If you don't see a potential of contaminated land, you can sell the biochar as a soil amendment or remediation material to someone else, or use it in a different project where you need it. And you can also earn carbon credits through different verified programs that there are. In fact, there are new things that are coming up, and in addition to carbon credits, there are also biochar specific credits that are being generated. So the economics eventually work out in your favor, that the on-site pyrolysis ends up being cheaper than landfilling, and it eventually produces a remarkable and marketable product that sequesters carbon and also cleans the soil and water, whether on the same site or somewhere else. So, coming into the studies that are done on biochar, that it is increasingly used as an in situ remediation amendment because of its highly porous and reactive carbon structure that we just saw earlier. It can intercept and retain a broad range of contaminants within the soil profile. And when applied to a subsurface layer or mixed into soils, biochar actually creates a sorptive barrier that kind of draws dissolved contaminants towards its surface and just holds on to them. So this mechanism is particularly effective for something like a PFAS, where biochar can absorb both long and short chain compounds, with metal activated biochars achieving removal efficiencies exceeding 90% in some applications. And activated biochars is a whole different ball game. It has more chemistry involved, but even regular biochars are having great results with PFAS these days. So heavy metals such as lead, cadmium, chromium are also immobilized through surface complexation and ion exchange, which end up reducing the mobility and bioavailability as we talked earlier. You also have some organic contaminants, including petroleum hydrocarbons, PAHs, which bind strongly to the carbon surface, while the nutrients like nitrogen and phosphorus are retained, limiting the leaching and eventual downstream eutrophication. So, all these uh, harmful algal blooms or HABs that you might have heard of, that are ending up in lakes or fairly stagnant waters, you can just have a soft which are near the point source or even a non-point source that is feeding the lake, and eventually prevent that sort of a harmful algal bloom. So this is the big picture, the circular loop that ties both halves of the talk together. We have a renewable energy project that once it's approved, you have vegetation that is cleared as part of the site preparation. And instead of disposing it off, you actually convert it into on-site potable pyrolyzed biochar. And this biochar produced can be deployed for remediation either on the same site or on a nearby piece of contaminated land. And the result of all of this is a cleaner land, a sequestered carbon, and a project that's more sustainable than it would have been otherwise. And there are so many different certification programs that are coming up for infrastructure projects such as Envision and others, where you can actually apply for these credits. In addition to this, the compliance conditions like vegetation management plans, stormwater BMPs, mitigation requirements can actually enable and incentivize this biochar production. So that's how you can eventually turn compliance into innovation. And one of the projects that we are working on right now, we are trying to build up a proposal around this where there's about 100 odd acres of land where that vegetation can eventually be converted into biochar, but that's still in development. So, five things that I hope you'll walk away with as part of this presentation is that permitting is the backbone of a responsible renewable energy project. It's not actually a bureaucratic hurdle as you think of, but it's actually a framework for ecological balance. The second one is the solar and wind have different permitting needs, but both follow the same mitigation hierarchy. First is you avoid the impact. If you can't avoid, you minimize the impact. If you can't minimize, you restore the impact. And if you can't do either of this, you offset the impact. The third one is that vegetation cleared during this site prep is a resource, but not a waste. And by all means, this is a true fact. So once you convert this into biochar, it turns an obligation into an opportunity. The fourth one is that the remediation grade biochar can address PFAS, heavy metals, hydrocarbons, nutrients, while sequestering carbon for centuries. And one of the most important questions that come up in some of the discussions that I have done is how many chemicals can it address and to what extent it can address. So one clear information that needs to go out is it does have its own adsorption capacity. So once its capacity is met, it will stop taking in more, but you can always add more biochar to make sure that the remediation is complete. The last thing and the most important is that the future of renewables is circular. It's not just about creating energy out of an infinite resource, but actually giving it back. And when we align the compliance with innovation, we can actually create deeper and more durable sustainability efforts. So thank you very much for your time. I am happy to take questions, and if we don't get enough time here, I've also shared my LinkedIn information. And if you would like to set up a call with me to discuss anything you would like.
Yeah, wonderful, wonderful. That was a very innovative presentation. I was wondering how you are going to connect that two ends, but
Yeah,
well, now I know. So thank you. As you
thank you.
know, like there will be a breakout room
Yeah.
after we are done here.